Welcome to this session. In this session, we are going to discuss a problem on numerical integration by Simpson's third rule. So the first part of the question is, find the exact value of the integral -1 to 1 of the function 1 over x plus x squared dx. And then part B is to approximate the function, the integral given in A by Simpson's third rule using a number of intervals. So there are 4 intervals, 6 intervals, 8 intervals, 10 intervals, and 12 intervals. So this is how we are going to solve this. We'll do part A, and then part B, Roman 1 and Roman 2. In the next section, we'll do Roman 4 and Roman 5, Roman 3 and Roman 4. And lastly, we'll finish with Roman 5. So solution. A, integral from -1 to 1 dx over 1 plus x squared. From calculus, integral of this integrand is tan inverse of x. And then you apply the limits, which will be tan inverse of 1 minus tan inverse of -1. When you work out this one, it will give you pi over 2, or which is the same value as 1 point. At the same value of 1.5 as 7, 1.570 79 6 3 2 7. Remember to do this computation, ensure that your mode is in radian. The mode of your calculator must be in radian for you to get the correct value. If the mode is in degrees, you'll get a wrong answer. That's a very key element that you must always remember when it links to trigonometric functions. And then part B, Roman 1, is to take n to be 4. Now, n to be 4 means h will be 1 minus 1 over 4, which will be 2 over 4, which is a half. And then this means we'll make a table of values. Remember, in this case, the function f of x is 1 over 1 plus x squared. So we are starting with -1. When you add a half, you get -1/2, 0, 1/2, 1. When you put the value, you'll have x, so put -1/2, you get a -1. In this function, you get a half. Next, will give you 4 over 5, 1, 4 over 5, and then this a half. And from this table, this will be f0, this is f1, this is f2, this is f3, this is f4. And remember, by Simpson's rule, Simpson's third rule, integral is h over 3 into x plus 4o plus 2e, where x means sum of end ordinates, o means sum of the even odd ordinates, and e means sum of the even ordinates. So a half is our h, dividing by 3 is 1 over 6. So end ordinates would be a half. Okay, so this is the formula, h over 3 into, so x sum of end ordinates will be f0 plus f4 plus 4. Odd ordinates means f1 and f2. f1 and f3, not f2. And then even, remember, you don't pick for f4 because f4 was the end ordinate. So the only even remaining is F2. So don't make that mistake of adding F4 here. F4 is not taken because for this given case, F4 is an endpoint. So you can't include F4 in this part and also this other part. Each value is just input once. Now a half plus a half plus 4 into 4 over 5 plus 4 over 5, and then plus twice, the other one is 1, this F2. When you simplify this, you get 1 over 6 into 1 plus 32 over 5 plus 2, which will give you 1 over 6 times 47 over 5, which will be 47 over 30. You can change into decimal as 1.56. So error in this calculation will be given by the correct value of two values, a half pi minus this value 47 over 30, and this gives you 4.129660128 times 10 raised to the power negative 3. Percentage error will be the error E1 over the true value, a half pi times 100%, and this will give you 0.262902391%. If you compare with what we did in the case of trapezoidal rule, when n was 4, the error was 0.02 and percentage error was 1.32%. So which means that this, compared to trapezoidal rule, this Simpson's third rule is more accurate than the other one because the magnitude of error here is less than the magnitude of error when you use the same number of intervals for the case of trapezoidal rule. And then part 2 of B, Roman 2, we expect to use n to be 6. So h will be 1 minus 1 over 6, which is 2 over 6, which is a third. Then remember the function f of x is 1 over 1 plus x squared. So make a table of values, x and f. So -1, add a third, you get -2 over 3. Add a third, you get negative a third. Add a third, you get 0. Add a third, you get a third. Add a third, you get 2 over 3. Add 1 over 3, you get 1. And when you input these values of x into the function, this will get a half. This will be 9 over 13. This will be 9 over 10. This is 1. This 9 over 10. This is 9 over 13. This is a half. Please confirm those values. And I advise when you're filling this table, unless it is impossible, express your values as fractions so that you don't have errors in the computation. Because immediately you start rounding off with this table, you are introducing errors in the calculation. So this is F0, F1, F2, F3, F4, F5, and F6. So by definition, I is given by h over 3, x plus 4o plus 2e, where x is a sum of end ordinates. So for this case, end ordinates are F0 and F6, and then plus 4 odd ordinates, we have F1 plus F3 plus F5 plus twice even ordinates. So we have F2 plus F4. Please, you do not add F6 because F6 has already been taken care of as being one of the end ordinates. So these are the only values we put here. So we'll have now I Remember, h is 1/3. So dividing by 3, you get 1/9 into a half plus a half plus 4 into 9/13 plus 1 plus 9/13 plus twice into 9/10 plus 9/10, close brackets. This will be 1/9 into 1 plus this one we get 124/13. The other one we get 18/5. So this is I, and this will be 1/9. When you add what we have in the brackets, you get 919/65, and this will give us 919/585. Please confirm those values. If you are to change that into decimals, you get 1.570940,171 as this approximation. So error, if we call it E2, will be exact values a half pi minus this approximation 919/585. We'll get 1.43844,145. 3 times 10 raised to minus 4. Percentage error, we get this error divided by the true value times 100%. And this will give us 9.1574 02702 times 10 raised to negative 3%, or 0.00. So this is what we got, what we get when n is 6. If you compare to what we did for the same number of intervals in the trapezoidal rule, the percentage error there was 0.5893%, while here the percentage error is 0.009157%. So you see, this is less than for the case of trapezoidal rule with the same number of strips or same number of subintervals. So we still confirms that if you compare trapezoidal rule and Simpson's third rule, then Simpson's third rule is a better approximation as compared to trapezoidal rule. Now, the remaining part 3 and part 4 will be done in the next session. So please watch the next session to see the solution for those two parts, 3 and 4. Thank you.